My name is Armando Lewis. I teach and I am a researcher at the University of Vieira. I'm going to be talking about artificial intelligence in the context of marketing efforts. Okay. Um, as you probably are aware of, marketing is about innovation, which is one of the key words of this conference. And um, it's also about a repeat business and building sustainable competitive advantages. Okay. And we are focusing on this research on trying to find out whether business people, directors, managers are already using AI tools in their marketing efforts, in their daily lives, in businesses, taking care of customers, um, providing services, etc., etc. Okay, because for example, in Portugal, at least in Portugal, I don't know in your countries, but little is known about. Well, everybody knows, everybody has heard about the artificial intelligence tools and technologies, etc., etc. But little is known about whether, in effect, in their daily lives, in the businesses, if artificial intelligence is being used. So this is one of the questions for this research. Is it being used for digital marketing purposes? And if not, or if not in an ideal degree or relevant degree, is there the potential for it? So what we did was we statistically selected, using SPSS, statistical software for social sciences. We selected 502 Portuguese companies. These companies are nominees or were nominees in 2023 for the Small Medium-Sized Leader Award, and based on their economic and financial performances. But they are not only excellent in terms of economic and financial performance, they are also using AI tools. I'm very happy to verify this. 1/3 or almost 1/3 of the companies use artificial intelligence to analyze the performance of marketing campaigns. Okay, and use artificial intelligence to analyze and to monitor online customer behavior, purchasing trends, etc. So AI allows us to do things that would take us in the old days, weeks, months, or years. We can do those things in seconds, minutes, hours. So it's a powerful tool. Okay. Almost half of these companies are using artificial intelligence for content personalization. I mean, content is the message, the content of the message, the marketing messages. Okay, because AI provides us with real-time data, and with that real-time data, we can do one of our main tasks, which is to make, between inverted commas, intelligent recommendations based on each customer profile that artificial intelligence is helping us with much quicker and much more effectively. Okay. Nearly 2/3 of these companies are using artificial intelligence tools for market segmentation, which is, I mean, one of the pillars of marketing. We cannot cover the whole market. That will be an utopia, a silly utopia. We need to concentrate, we need to focus our marketing efforts in segments and niches. Okay, we can do that much faster, and much more effectively with AI tools. And people in businesses, in companies, they are doing that already. Cost reduction, it's all about money, I'm sorry to say. Because if we don't control costs, we may go bankrupt. And all of this would be meaningless. So cost control is much more effective using AI tools, and businesses are doing that already in Portugal. Predictive marketing. Okay, this is the least represented activity, but it's only normal because we are just getting started in this new era, which includes a quantum component, quantum computing. That's another story, a different conversation, but it's related directly or indirectly to artificial intelligence. So, very interesting results. This is a work in progress. So the next step would be to detail even further this analysis. For example, according to the sector distribution in the Portuguese economy, retail and manufacturing, very important sectors. Also services, which includes tourism. Tourism is very important, it's fundamental in Portugal. We don't have oil, we don't have gold, we don't have a car industry, but we have almost 1,000 kilometers of nice beaches. We have good weather, good food, good tradition, culture, and sorry for the presumption, good people. So tourism is very important. Construction, of course, it's important as well, and also other sectors like transport and agriculture. So the next step would be to detail these data according to this sector distribution. So I end my presentation by showing you some relevant references, at least for me. Nowadays, I'm reading Martin Ford, The Future of Artificial Intelligence. I recommend it. It's very good. So thank you very much for your attention and for having me in this conference. And I hope to see you in other opportunities. Thank you very much. Thank you.
That was the presentation of Dr. Armando Lucy. I'd like to share his email ID in the chat box. Delegates, for any queries or any details, reach him through email ID. On absence of Dr. Hamin, I'd like to introduce for the next speaker, Professor Fanny Han. He's from the China, and he want to give his presentation on the truth with falsehood using the fact evidence graphical retrieval of enhanced LLMN for online public opinion fact and checking. Because of his absence, I want to share his video.
Hello, everyone. My name is Feng Yang. I come from Sun University in China. I'm granted here to take part in this conference. Okay, let me show my PowerPoint. Today, I would like to talk about the truth versus falsehood using fact evidence graph retrieval to enhance large language models for online public opinion fact checking. This is the table of the content, including introduction, the fact-based information verification, a fact-checking framework based on the large language models and fact evidence graphs, experiment, design and analysis, and implications. In recent years, with the rapid development of the Internet and its application, false information has spread quickly online, causing significant negative impacts in areas such as political and public health. Although professional fact-checkers are capable of identifying false information on the Internet, traditional manual verification methods struggle to keep up with the growing prevalence of the misinformation. As a result, research have studied inquire how artificial intelligence technology can be used to automate the fact-checking process for false information. Automated fact-checking of the false information is generally divided into the two categories. One is the content-based fact-checking, and another is the fact-based fact-checking. Content-based fact-checking focuses on learning various features of the information to be verified in the training datasets, such as linguistic features and emotion patterns. Although this approach has achieved some success, its effectiveness may vary across platforms due to its reliance on specific datasets for future learning. Additionally, the timeliness of the datasets and the emergence of large language models may make it difficult to identify newly emerging false information. So I would like to introduce the fact-based information verification. To improve the accuracy of the verification, researchers have gradually shifted towards fact-based verification methods and have proposed different fact-based verification models. These models verify the truthfulness of the fact by comparing various factual elements described in the statement, such as time, location, and names. This approach has been a key focus in the current domain of the misinformation detection. Of course, there are some challenges in current fact-based verification method. Existing methods generally employ smaller language models. However, compared to current large language models, smaller language models have a substantial gap in terms of parameter size and pre-trained datasets. This makes them less capable of handling complex logic tasks like statement verification. Due to the lack of the sufficient logic reasoning abilities, small models often struggle to accurately analyze the evidence retrieved for verification. So there are some limitations of the current research and the proposed model, such as insufficient relevance between the content and the statement to be verified, neglecting the inherent relationship between sentence during evidence retrieval, limited reasoning abilities in smaller language models. To address these challenges, we propose a novel model for online public opinion factor verification, which integrates large language models and a fact evidence graph. This model aims to enhance the verification process by improving the relationship between statements and evidence while addressing the logic gaps seen in the traditional models. So we propose a framework based on the large language models and the factor evidence graphs. The framework for online public opinion fact checking is mainly divided into 4 parts. Factual evidence graph construction, fact-checking content identification, evidence retrieval, fact verification. This is the framework based on the large language models. The specific implement framework consists of 3 parts. The graph structure indexes, the dual layer retriever, and the generator. The graph structure indexes first splits the factual evidence documents into smaller fragments, automatically identify and extract entity and their relationship using a large language model. Construct a factual evidence graph and converts the data into a vector for retrieval. The dual layer retriever then extracts relevant information from the factual evidence graph using 2 different retrieval strategies. The generator, based on the user query and retrieve the context information, uses the language model to generate a fact-checking answer that meets the requirements, ensure a balance between specific detail, such as people, events, and the broader context, thus enabling accurate fact verification and validation. So I would like to introduce the graph-based text indexing. The text indexing could be divided into 5 steps. Document splitting divided documents into text blocks that are easier for the large language model to handle. Entity and relationship extraction. Identify core entity in the document and their interrelationships. Concept summarization. Extract and summarize high-level concepts from the multiple text segments to enhance the abstraction capability of the graph. Merge redundancies. Combine duplicate entities and relationship from the different document sections to reduce redundancy and simplify the graph structure. Finally, the entities, relationships, and the high-level concepts in the factual evidence graph are converted into vectors and stored in a vector database, ensuring the efficient subsequent retrieval. I would like to introduce the 2-level retrieval enhancement process for fact verification. 2-level retrieval enhancement combines both fine-grained and micro retrieval strategies enhance the ability to comprehensively retrieve information across a different level of the knowledge discovery. The goal is to verify factor by extracting both specific details, such as people, events, and the broader concepts in factor verification text. It recognizes and presents key facts like the event, relationships, and timelines to support a detailed and multi-dimensional factor checking process. So there are 6 steps in this process. The first step is query analysis. The large language model analyzes the query to extract both high keywords and low keywords. The second step, fine-grained search. Low keywords are used to search through entity node vector databases, identifying related entity and retrieving associated relationships and relevant document fragments. The third step, macro search. High keywords are used to search broader relationship vector database, retrieving related contextual documents and reference. Then is the generation process. The large language model generates fact-checking answers based on the user query and retrieved factual evidence. The model integrates various information sources such as historical figures, events, location, and political background to generate comprehensive factual evidence. The fifth step is the information integration. The model combines low-level details information, specific entities and relationships, with high-level concepts, background, and abstract things to produce a well-rounded response. Then is the detailed fact-checking answer. The model generates details and accurate answers based on the retrieved evidence, ensure the historical accuracy and relevance of the information. I would like to introduce the experiment design overview. The experiment is still ongoing. I'm very sorry about I can't present the details. The experiment design, including the experiment setup, dataset, and dataset characteristics. So, based on the framework we proposed, there are some implications can be drawn. Large language model knowledge enhancement introduce fact evidence graphs to augment large model, improving online public opinion fact checking. Real-time fact knowledge updates ensure timely integration of the new evidence, maintain the effectiveness of the fact-checking in dynamic environment. Human-machine collaboration Focus on the principle, humors at the end goal to avoid over-reliance generative AI models. Enhance the robustness, leverage large datasets and more diverse evidence to enhance the robustness of the fact-checking system. This is the reference of our study. That is all my presentation. Thank you for your attention. Have a good time.